Drop a like and do share. Leave your comments and do not forget to subscribe for more videos.
Dear students, let's proceed further with our chapter hydrocarbon. We are doing the subsection alkene. In our earlier videos, we have covered the structure, the nomenclature, and the preparation. Okay. In this video, we will be studying the properties of alkenes, physical properties, and the chemical properties. So let's proceed with the physical properties. First of all, the melting point. Generally, the alkenes will have higher melting point than the corresponding alkanes. If they have the same number of carbon atoms, then the alkene will have higher melting point. And reason for this is that in alkenes there is a double bond. Okay, and the p electrons, they are more polarizable as compared to the s electron. As a result, there will be dipole moment, and so there will be higher intermolecular forces of attraction as compared to the alkanes. As a result, the melting and boiling point in general will be higher than the corresponding alkenes. Next, the melting and boiling point of alkenes in general increases with increasing molecular mass, because with increase of molecular mass, the van der Waals forces which depend on the weight will also increase. So higher forces of attraction, so higher melting and boiling point. Again, it will also depend upon the dipole moment. So cis has higher dipole moment, and trans, they are generally dipole moment is 0, so it should have higher melting and boiling point. Okay. Next, boiling point of alkenes in general, they show a gradual gradation. Okay, and there is an increase with increasing number of carbon atom, just like the alkanes, and with subsequent addition of a carbon atom C or the group CH2, the boiling point will raise by 20 or 30 degrees. Next, the dipole moment. So alkenes, they are weakly polar because the p electrons, they are more polarizable. So there will be a dipole moment. Okay, and now we can have cis or trans. Okay, so trans, they are symmetrical. If they will be non-polar if they are symmetrical. If not symmetrical, then they might have some dipole moment, but it will be lesser than that of the cis alkene. Okay, so we have seen about how its dipole moment, they cancel out each other in our previous video. Okay, you can refer those. Next is solubility. So first of all, related to density, the alkenes, they have low density as compared to water, so they are lighter than water, and at the same time they are insoluble in water because they are not that polar. They are very weakly polar, so for practical purposes they will be considered as non-polar. Okay, so they are not soluble in water, so they are lighter than water, not soluble. So if we pour them in water, so they should float. And then how, if we have to dissolve them, so what kind of solvent we require? So they are readily soluble in organic solvent, and alcohol is considered the best organic solvent, and that's why it is used in various industrial purposes, in reaction or in cosmetic industries. This is used, alcohol is used as a solvent to dissolve other organic compounds. Then benzene, ether, and carbon tetrachloride, these are all other organic solvents which are generally used in any organic chemical reaction. Next, come to the chemical properties. So first is addition of halogen. Okay, we have studied about this in preparation of alkanes. If we add the molecule of hydrogen gas, dihydrogen, okay, so in presence of some catalyst like nickel, palladium or platinum, then alkane will be formed. For example, like take so if we add hydrogen gas and then use a catalyst, so they will get attached to it, and from the alkene we will get an alkane. Okay, similarly we can do for other higher alkenes to get an alkane. Second is addition of halogen. Okay, so halogen like bromine or chlorine, they add up with alkene to form vicinal dihalide. Okay, for example, like take ethene, and if we add bromine to it, so we will get a vicinal dihalide. Br will be attached here, and similarly Br will be attached to the other carbon atom. Okay, and this is used as a test for unsaturation, like bromine solution in carbon tetrachloride, that is used as a solvent. Okay, so it has the reddish orange color. Okay, so when the bromine will add up to the double bond, so this color will fade up. So this will be used as a test for unsaturation. So if color fades up, that means there is a site of unsaturation. Okay, and what kind of reaction is this? We have studied earlier that it is electron rich and any electrophile will attack, so it is electrophilic addition reaction. We have studied about all these types of reaction, electrophilic, nucleophilic, in our previous chapter GOC. You can refer those videos. Okay, similarly addition of hydrogen halide, so the same reaction will happen, and then H will attach to one carbon and then bromine will attach to other carbon, or if we use chlorine or iodine, the similarly H will attach to one carbon and halogen will attach to other carbon. Okay, for example, right, so H will go to one carbon and Br will go to the other one. Okay, hydrogen halide is added to it, addition reaction. Okay, again, now the order of reactivity will be similar, like Hi greater than Hbr, then greater than Cl. Okay, it is again similar. This is electron rich and this is electrophile, so it is electrophilic addition reaction. Next, we have to study one Markovinkov rule. For example, like earlier we were studying the hydrogen halide addition. Okay, so there are two possibilities. Either H will attach to the middle carbon and Br will attach to the terminal carbon, or H will attach to the terminal carbon and Br will attach to the middle carbon. So there are two possibilities. Okay, so now how you are going to tell whether these two products, they will be equally formed, or one of the product will be major and other will be minor. So here there is a rule known as Markovinkov rule given by Markovinkov, to simply you can tell which will be the major product. Okay, so if there is an addition reaction across the unsymmetrical multiple bond. So if there is symmetrical multiple bond, so it will be same whether you attached one way or the other way, it will be same. So problem comes in unsymmetrical multiple bonds. Okay, so the negative part joins the carbon atom which carries small number of hydrogen atom, whereas the positive part goes to the carbon atom which has more hydrogen atom. So here in case of HBr, we can break HBr into H plus and Br minus. So H plus is the positive part, so it should go to the carbon atom which is having more number of hydrogen atoms. So in this two, this is having 2 hydrogen atoms, this is having 1 hydrogen atom. So H should come to this, it should attack here, and Br should go to this position. So we should get 2-bromine as our predominant product. Okay. Now let's analyze why it is happening as such. Okay. So first of all, the electrophile is going to attack. So either it will attack the carbon at one position or at the 2 position. So let's see. Suppose it attack the carbon at the center. Okay. So this will attack. So at first position there will be a carbocation. So it is 1 degree carbocation. It is less stable. Now if suppose the hydrogen it attacks the terminal position, so a carbocation will be formed at the center. This is 2 degree carbocation. This is 1 degree carbocation. This is 2 degree carbocation. In hyperconjugation effect we have studied, the more number of beta hydrogen are there, it will be more stable. Here 6 beta hydrogen are there, whereas it has only 2. So they will have 7 hyperconjugating structure, it will have only 3. So this will be more stable. So that's why 2 degree carbocation is more stable than 1 degree carbocation because of the hyperconjugation. Okay. So since it is more stable, so reaction will proceed via this route, not via this route. Because if we see the reaction coordinate is the reactant and then the product, so between the reaction and product there is a hill which need to be crossed, that's the activation energy. So in case of this, since it is more stable, so activation energy will be lower, whereas in case of this primary carbocation, this activation energy will be much higher, this hill will be much higher. So it will be very difficult for the molecule from here to migrate to this hilltop so that they could form the product. Okay, in case of this one, whereas in case of this one, it is activation energy is lower because second degree carbocation is more stable. That's why this product will be formed at 2 position 2 bromopropane. So simple, just if you see the reaction, you have to attach hydrogen atom to the carbon atom which already has more number of hydrogen atom. Simple, it's the Markovinkov rule. Hydrogen atom goes to that carbon which is already having more number of hydrogen atom, and the negative part will goes to the other carbon atom. So is there any exception? Yeah. So it is known as Anti-Markovnikov addition, or it is also known as Peroxide effect or Kharash. What will be different here is, along with these reagents, we will also add a peroxide to it. Okay, and now the mechanism will be radical mechanism, not the electrophilic mechanism. Okay, and here the product will be 1 bromopropane. The H will add to the position where there were less number of hydrogen. H is attaching over here. It has only one hydrogen, and the negative part will go to the carbon atom which is having more number of hydrogen atom. It is going here. Okay, so let's see what is happening in this reaction. So reaction mechanism is as follows. First of all, like there is a peroxide. So here we have used benzoyl peroxide. So on heating it will break, and then we will get a free radical. So HBr bond is weaker, so this will break. This free radical will attack the H and Br will be formed. Now we have a free radical, so it will attack the alkene, and so there are two possibilities. Either it can attack the terminal position, or it can attack the center position. So if it attacks the center position, so we'll get a primary radical that will be less stable. If it attacks the terminal position, so we will get a secondary free radical. So it will be more stable. So reaction will proceed via this mechanism, and then again the free radical will attack the HBr molecule because this bond is weaker. Okay, and then we will get 1 bromopropane as a major product, and the other product will be in very less quantity, minor product. Whereas in organic chemistry we focus more on major product. Okay, so if we have to write, so please mention 1 bromopropane as the product. Next is addition of sulfuric acid. So cold concentrated sulfuric acid, they adds to the alkene and they follow Markovinkov rule. So simply H will attach to the carbon having more number of hydrogen atom. Here it is symmetrical, so it doesn't matter whether you attach to this carbon or that carbon. But when it is unsymmetrical, then you should attach the hydrogen atom to that carbon atom which is already having more number of hydrogen atom. Okay, you will attach H to it and rest the molecule to the other carbon atom. Simple electrophilic addition reaction. Similar with the water. If we add few drops of water with the concentrated sulfuric acid, then it will react to form alcohol. Same, it will follow the Markovinkov rule. All the electrophilic addition reactions, they will follow generally the Markovinkov rule. H will goes to that carbon atom which is already having more number of hydrogen atoms. So H will come to this position and OH will go to the other position, this carbon. So H is coming here, OH is coming here. Next is oxidation. The first is hydroxylation and second is oxidative cleavage. So here the molecule will not break, that carbon-carbon bond will not break and only OH will be attached, whereas in oxidative cleavage the carbon-carbon double bond they break. Okay, so let's first see hydroxylation. In this, alkene react with cold dilute aqueous or alkaline potassium permanganate solution and on addition they form vicinal diol, 1,2 diol, which is generally known as glycose. In glycose there are 2 OH groups on the adjacent carbon atom, and in this reaction there are two hydroxyl group which is being attached to the double bond. That's why they are known as hydroxylation of double bond or the hydroxylation reaction. So it's simple. Cold dilute alkaline potassium permanganate. Simply you have to attach OH to the two position. OH, nothing different. Okay. Next, proceed to oxidative cleavage. In this case, we use hot acidic. Okay. So temperature will be high and it is acidic. Potassium permanganate solution or potassium dichromate solution. And in this case, the double bond will split and either it will form carboxylic acid or ketone depending upon the situation. Okay. And since the double bond is breaking, so it is known as oxidative cleavage of alkanes. Oxidative because an oxygen is being added. Okay, oxidation is taking place, and cleavage because the double bond is breaking. So simply you have to just break the double bond, attach an oxygen. So here if you attach oxygen you will get a ketone, whereas if you attach, so it is H, C double bond O and H. This is not stable and further more oxidation will take place and it will oxidize to carbon dioxide and water. Similarly, if you attach, break this, you will get CH3, CH and O. But this is in acidic medium, so it will further oxidize and you will get an carboxylic acid. Okay. So simply just cut the double bond, attach an O. Okay. And if it is aldehyde, then it could be further oxidized to carboxylic acid. If it is ketone, so ketone cannot be further oxidized. And if you get this formaldehyde, then formaldehyde, both these two CH bond, they could be oxidized and you will get carbon dioxide and water. Next is ozonolysis. If alkenes, they are reacted with ozone, they form ozonides. Okay, these ozonides, they are very unstable compound. Okay, and they could be reduced further by zinc or water, which could form aldehyde or ketone depending upon the situation. For example, if you simply, you have to just cut this molecule and attach oxygen between this carbon and two oxygen between these two carbon and you will get ozonide. And this is the intermediate structure and it will further break down into either aldehyde or ketone. Okay, so simple is just cut and then attach an oxygen. So CH3CHO. Similarly, CH2 and O. So HCHO. It will depend whether aldehyde is forming or ketone. It will depend on the structure of the alkene. Next is polymerization. So what is polymerization? Polymer means large number of monomers when they attach to each other. So it forms a poly. Poly means many. Okay. Mono means one. So in this process, a large number of simple small molecules will combine to form a very big molecule which will have a very high molecular mass. So it will be known as polymerization. And the basic unit from which the polymer is formed is known as monomer, and the macromolecule is known as polymer. So for example, like ethene, if it is can be polymerized at very high temperature and pressure using a catalyst. So one ethane molecule will attach to the other and they will form polyethylene. So whatever the polyethylene bags etc. we see from its name from this polyethylene. Thank you.